my new BC people, y'all are obviously coming in from ahead of us, so I still expect you to participate. I don't mind if you kind of work on the homework simultaneously. I'll have to get more copies, since I obviously did not expect so many new people, but we're going to do some of it today. So if you did not get a copy of the homework, I'm going to have you get out a sheet of paper. You're going to do it on a separate sheet, staple it, and it'll be totally fine, okay? Chain rule is taking the derivative this is what it's for. We're going to do a formal definition in a second. Taking the derivative of compositions of functions. Okay? Which is this. Do you remember that? FOG of x. Okay, so the little open circle stands for composition, and you should at least somewhat remember that that's f of g of x. Okay? So it's kind of like the exact same thing of just this versus this. The good news for you is that the AP test, they're not going to use this notation. Okay, they're going to give you the right side, which I think is easier most of the time to look at. Okay, but we're going to do a quick chain rule or gnaw game. Okay, are you ready? Okay. So, you're going to tell me, is it going to be a composition of functions or gnaw? Okay, ready? Sine of 2x and 2x times sine x. Okay, write them both down. For the first one, is one function plugged into the other? Yes, this is chain rule. Okay, look at the second one. It's 2x times sine x. Is one function inside the other function? Okay, nah. Okay, what rule, based on Friday, would you use to take the derivative of that second option? Okay, that would be a product rule. So if you want to put PR for product rule, okay, that second one would be a product. Okay, ready? Let's do one more. Square root of 4x plus 2 and 4x square root 2.
Is the 2 inside the 4x?
Yes. Okay, look at the first one. Is one function plugged into the other? Yes, then it's chain rule. Okay, but look at the second one. If it's 4x times square root 2x, that is not chain rule. Okay, so make sure that you understand the difference. If it's a product, you're using product rule. If it's one inside the other, that's when you'll use chain rule. Now, let's actually define chain rule, please. Okay, for f of x and g of x, both differentiable functions, the derivative d dx of f of g of x is, okay, you can maybe put a star here, this is your rule, f prime of g of x times g prime of x. To make the notation a little bit simpler, okay, I'm going to replace g with just a u. So the derivative of f prime of u would be f prime of u times u prime. Okay, this is the notation that I'm going to typically use in class. This one is fine, but it's just a lot more parentheses and x's all over the place. Okay? So I'm going to start you off with a couple of easy ones. Okay, we're going to advance to harder problems. So for the first one, I want you to take the derivative of sine 5x plus 2. Sine 5x plus 2. Okay, so first thing that I want you to think about is, what is the outside function? Is it the sine or the 5x plus 2? Okay, it's sine. And then I'm going to put of u, just pretend. So all of that stuff in the middle, that's my u. Well, then the derivative of sine u is going to be, what's the derivative of sine? Cosine u times u prime. That's my rule. F prime, I take the derivative of the first function, but then I multiply by the derivative of the middle function. So think about, if I want to take the derivative of this, the derivative of sine is cosine. Notice that in my cosine, u stays the same. But then I multiply by u prime. What would the derivative of 5x plus 2 be? Just a times 5. So this is the same exact u. Same u. This is u prime. So I keep the u the same when I derivatize the outside, and then I multiply by the derivative at the back. Okay, we're going to do like a million of these, so if that one was confusing, let's try one more. Okay, number 2. Let's say that you want to take the derivative of cosine 8x. Oh. My dentist has called me like 100 times because I have an appointment tomorrow, but I already told him I was going to be there. Okay, what's the derivative of cosine? Negative sine. Do I change the 8x right now? No. And then I'm going to multiply by the derivative of 8x. What's the derivative of that? 8. Now, on the AP test, typically they will not leave those constants at the back. So I'm going to rewrite this first one as 5 cosine 5x plus 2. And I'm going to rewrite this second one as negative 8 sine 8x. Yes. Okay? So the first one's not wrong. If it was free response, you'd get full credit. Okay, but if it's multiple choice, you need to know how they're typically going to write it. Okay? Good? All right, next one. I'm going to have to turn the page. Are we good? Okay? All right, number 3. Y equals 2x cubed plus 7x to the 5th power. I'd like for you to find y prime. So, think about my outside layer, if you will, is the 5th power part. Okay? So, how do I take the derivative of u to the 5th? Okay, well, the derivative would be the 5 moves down to the front, u to the 4th, but then times what if it's a chain rule? U prime. So I bring the 5 down to the front. This stays the same, but I knock the power down one. Then I multiply by the derivative at the back. So let's do that here. My 5 moves down to the front. What is the new power on 2x to the 3 plus 7x? 4th, but then I need to multiply by the derivative of the middle. So if this is my middle, what's the derivative of that?
6x squared plus 7.
Okay. Now, typically they would write it with that last thing first. Okay, so I'm going to rewrite it, but on your homework, that's up to you if you feel like you need to practice that. So that would be or 5, 6x squared plus 7, 2x cubed plus 7x to the 4th. Okay? All right, let's do another one. I'm going to give you some to practice here in a minute. Okay, that's why I'm not going like super slow. Okay, so y equals e to the 3x squared plus 5x. Okay, let's write our chain rule version. So if this is e to the u, this is just kind of scratch work over here. What's the derivative of e to the u? E to the u times what? U prime, right? So the derivative of e to the u would be e to the u times u prime. So come back over here, it'd be e to the 3x squared plus 5x times, and then if my u is just the little exponent, 6x plus 5. Now, are the parentheses necessary around 6x plus 5? Yes. The reason why is because if you don't put that plus 5, only the 6x is multiplied with e. That's not what you mean. So make sure if this u prime has multiple terms, you do have to group it. Okay, so I'm going to put here, you must group 6x plus 5 in parentheses. Okay. Alright, next one. Let's do sine y equals sine to the 6x. Okay, now this is a different notation maybe than you saw in pre-cal. Okay, but typically on the AP test, this is the same as this. Okay, the reason that they do that is they don't want you to think that, like, if they put the 6 here, they don't want you to think it's like x to the 6. So they want you to know the entire sign has that power on it, okay? So these are the same. We'll do several examples like this. So let's take the derivative. Y prime equals. Okay, think about this is like u to the 6. So what would the derivative of that be? Bring the 6 down. U to the what now? 5 times u prime. And now I'm going to apply that here. So my outside function is something to the 6th power. Well, then I'll multiply the 6 down to the front. What's the new power on sine x? The 5th power. But then I have to multiply by the derivative of the middle. So if it's a sine x, what's the derivative of sine x? Cosine x. Now, again, they're not going to leave it like that on the AP test. So I'm going to rewrite it for you. They'd put 6 cosine x first. And then when they get to the sine, they'd pop that 5 back in right there. These are the same, though. Okay, this and this are exactly the same thing. Okay, the only difference is where you write the exponent. Okay? Next one, I'd like for you to take the derivative of tan 8x squared. Okay? In order for you to do this one, I don't think we've done the derivative of tan in class. I want you to get out your pink sheet. Okay? So your pink sheet has all the derivatives on it that you're going to need all year. Okay, so on the derivative side, it says differentiation rules at the top. Your trigs are all kind of down that right side. Okay, find the derivative of tan on there. Okay, what rule number is it?
16.
Okay, good. And now notice that your rules on here, do you see how they all have a u prime at the end?
Yeah.
Okay, that's because these are already the chain rules for you. So, does anybody else need one? Okay, so what's the derivative of tan u? Secant squared u times u prime. So, I'm going to come back to my sheet here. The derivative of tan 8x squared, if it was a tan u, then it would be secant squared u times u prime. So the derivative of tan 8x squared would be secant squared 8x squared times what? 16x. Yep. Okay, so you keep that middle part the same when you're doing the outside function, and then that part's derivative goes at the back. Make sense? So far, so good? Probably being quiet. Is that good or bad? Okay. You would not have to rewrite it for the AP test. They might put the 16x first, but hopefully, you know, it would be obvious enough that you wouldn't be worried about it. Okay, and then again, it's at your own discretion. If you feel like you need to practice that on your homework, then do it, okay? But if you feel like, you know, you're fine with that and it doesn't make a difference, that's fine too. Okay? All right, I'm going to do one more with you, and then I'm going to give you some homework questions to do, and I will write them up here since some of you don't have it. So, number 7, the last one before we try some homework, is going to be y equals the ln of sine x. y equals the ln of sine x. Now, we've already learned the derivative of ln x. What's the derivative of ln x? Okay, look on here for the ln of u. It's on there. It's on the left side. You see the derivative of ln u? Right here. Okay, what is it? 1 over u times u prime. Now, instead of writing it separate, you could also just put u prime over u. Are we comfortable with both of those? Okay, so let's use that rule here. So, ln u, the derivative is 1 over u times u prime. What's my u in ln sine x? What's the middle function? Sine x. So it'd be 1 over sine x times the derivative of sine x. What's the derivative of sine x? Cosine x. Okay, or I could just put u prime over u and write it as cosine x over sine x. Okay, that is already, what were you going to say? We were about to put. So that's already a trig identity. If you look at the bottom here, what is sine over cosine? Tangent. What is cosine over sine? Cotangent. So you could also write that as cotan x, which is probably what they would put on the AP test. Okay? All right, take a look at your homework, please. I'm going to have you do numbers 2 and 4.
Wait, what homework? 12?
The one that you were supposed to pick up today, but we ran out. So I'm going to write them up here. If you don't have a homework, get out loose leaf paper so you can just staple it. If you do it in your notes, you're going to have to recopy it. That'll be annoying. Okay, so homework examples. Number 2 is y equals 3, 4 minus x squared to the 5. Number 4, right next to it, is cosine 6x squared plus 5x. And then number 5, I'm also going to have you do, and it's e to the x squared plus 5x. Okay, so try those 3. Then we'll do some harder examples here in a minute. Huh? Which one? So that'd be 15 in the front, 4th power, and then the derivative of that is not just x. So the derivative of 4 goes away, but it's a minus x squared. So what should u prime be? And then negative 2x. So like you'd multiply these together. So it's 15 times negative 2.
Is that like in full response?
No. For your response, you can do whatever you want. But if it's multiple choice, you'd have to know like what are they probably going to do to mix up the answer to make it not look like that. Does that make sense?
Yeah.
So that's why like on the homework, if you leave it like that, I'm not going to count it wrong because it's technically for your response. But if it was multiple choice, you need to know, oh, there it is. Make sense? Nope, it's right. And then you did cosine, negative sine, blah, blah, blah. Yep, second one's right too. So then do number 5 next. Yeah. Yeah. So now it's 15. And then put parentheses to show that all of that is Yep. You may also put the negative in front, but I mean it's not wrong. We have it written, but that's just probably what they would do. Okay, let's see how you did on the first one. Okay, what's my coefficient when I bring the 5 down? Okay, 15. 4 minus x squared used to be to the 5th, now it's to the 4th. Then I need to multiply by the derivative of the middle. Derivative of 4 is 0. What about negative x squared? Negative 2x. Then I'm going to multiply these two guys together. 15 times negative 2. What would that be?
Do we have to multiply?
No, not really. Sorry. It just depends if it's multiple choice or not. I'm just gonna wait. Sounds bad. So if going great. If okay, if it's multiple choice, you'd have to know which one's the same. But if it's free response, that's good enough. Okay. Next one. What's the derivative of cosine?
Negative sign.
Negative sign, but then the middle part stays the same, so it'd be 6x squared plus 5x times
12x plus 5.
12x plus 5. Then from there, they'd probably multiply this with the negative, so they'd probably put negative 12x plus 5. And then the sign 6x squared plus 5x. Okay, but again, these are the same, so it doesn't matter which one you put if it's free response. If it's multiple choice, the reason we're going to practice this is so you kind of know typically what they would do. Okay? Last one, number 5. Y prime would be e to the what? X squared plus 5x, so same thing, but then I'd multiply by the derivative, it would be what? 2x plus 5. Very good. Make sense?
Is that a negative on that one? Negative.
That is a negative, and then I started to write side and I just crossed it out.
Oh, because you multiplied sign by.
Now, question, are these parentheses necessary? Yes. If you don't put them, this is what that means. Negative 12x plus 5 sine 6x squared plus 5x. That's not right. So those parentheses do have to be there for two reasons. They make the negative apply to the 12x and the 5, and they make the sign multiplied by both. So those do have to be there, or else your answer's not right. Okay? All right, back to your notes, please. We'll try to work some more homework examples in here in a minute. Next one that we're going to do, so this is number 8 in your notes, is we're going to do y equals 2 divided by 3x plus 4 to the 5th power. Now, when you look at that, you might think, oh, that's quotient rule. Okay, could you do quotient rule? Yes. That's going to be way harder. The easier thing for you to do would be to rewrite it. So I'm going to keep the 2 in the front, and then how can I bring this up if it's on bottom? I'm going to use a negative exponent. So it'll be still 3x plus 4, but I'm going to write it to the minus 5. Okay, so since I'm bringing that term up, I just switch the exponent to be negative. Then from there, I'm going to write y prime. So think about your rules, give it a shot. You probably can do this one. Okay, what would my first number be in the front? Okay, negative 5 times 2 is negative 10. What's the new power if I take away 1? Negative 6. Good. Times. And then your derivative of the middle, 3x plus 4, what is it? 3. Okay, what two things would they probably combine? What's negative 10 times 3? And where would they put the crap to the negative 6? On the bottom. So 3x plus 4 would go down to the 6th power. Okay, this is probably what they would put as your answer, not the other one. Okay? Alright, I'm going to give you another one like that. Ready? Only 3 more examples. And then we're going to look at your homework some more. Okay? Next one is going to be y equals. It's going to be 2 over 4x squared plus 8x. Okay, I want you to rewrite it. Think about it for a second before I do it. Your 4x squared plus 8x is on the bottom, but there's not a power written. What power is it? A 1. So when I bring it up, what's it going to be? -1. So 4x squared plus 8x, but now it's to the -1. Okay? Take your derivative, write it down please, then we'll check it. So I'm going to call it dy dx just to change up the notation. But remember, dy dx is the same as y prime. Exact same thing. Okay, multiply the -1 down. What's my number in front now? -2. Then 4x squared plus 8x is now to what power if I minus 1 more? Okay, -2. Am I done? No, multiply by the derivative of the inside. What would I get in there? 8x plus 8. Very good. Then from there, I'm going to rewrite it because remember, part of the test is multiple choice. What two parts will stay on top?
-2 and 8x.
Good. And then this part is going to have to move to the bottom. So I'm going to put that part is going to move down. But the other two parts are both going to stay on top. So I'd have a -2, 8x plus 8. On bottom, 4x squared plus 8x squared. Now, is there one more thing that they could take out on the top? They could take out an 8, right? Okay, they could GCF an 8 out. So instead of a -2 in front, if they did that, it'd be a -16 and then an x plus 1. Okay, but remember that both of those are fine. Doesn't matter which one you do. Okay? Alright, next one's going to have a square root in it. Y equals 12 square root 2 minus 4x. 12 square root 2 minus 4x. Take a second and rewrite that for me. How would we rewrite it? 2 minus 4x to the 1/2. Very good. Remember that a 1/2 and a square root are the exact same thing. Okay, so now take a second, write dy dx equals. Even though that's the same as y prime, we want to practice writing both. Okay, my 1/2 is going to multiply down on the 12. What's half of 12? 6. 2 minus 4x. I need to take away 1 from a half. So minus 2 halves. What's 1/2 take away 2 halves? -1/2. Because it's positive 1/2 minus 2 halves. Okay, then from there, am I done? Derivative of the middle. What's the derivative of 2? 0. What about the minus 4x? -4. Okay, the middle chunk is going to move down, but the 6 and the -4 are staying on top. What is 6 times -4? Okay, these two are going to combine to be a -24 over. And then on the bottom, my 2 minus 4x is going to come down to the denominator. If it was to a -1/2, what should it be under? Square root. Very good. Okay. All right. One more left. Okay, y equals 2x to the 5th plus tan x cube rooted. Okay, rewrite it for me. 2x to the 5th plus tan x. What exponent would I use? 1/3. Okay, take a second, take your derivative, please. And then I want you to try to rewrite it in radical form. That means you should be using the root symbol, not just leaving a bunch of exponent powers. Do you remember the derivative of tan x from before? What was it? Secant squared x. Okay, so when you get to that part, tan x, the derivative is secant squared. Okay? My 1/3 moves down to the front, so it's 1/3. 2x to the 5 plus tan x used to be to the 1/3 power, but now I need to minus 3/3. Negative 2/3. Then I need to multiply by the derivative of the inside. What is 2x to the 5th's derivative? Okay, 10x to the 4 plus. What's the derivative of tan? Secant squared x. Okay, if you haven't rewritten it already, only this term really needs to move. So it will be 1 on top, 10x to the 4 plus secant squared x, over, and then on the bottom, where am I going to put the 1/3? Just put a 3 down there. Okay, that's the same as a 1/3. The 3 just goes on the bottom. Then my 2x to the 5 tan x. Remember, the top number is the power. The bottom number is the root. So it's to a power of 2, and then it's a cubic root. Make sense? Okay, good. Okay, I lied. There's one more in the back. Sorry, I didn't see it. I wasn't lying on purpose. Okay, but one more. Really, there's 10 more. I'm just tricking you. The breadcrumb idea. Just one more. For like 5 years. Okay, this is the real last one. Okay, look, see, it's the end. Then there's no more. Okay, good. You do have to rewrite that. Yep. Okay. Sin x plus 6 is under a root. So what fraction am I going to use?
Negative 1/2.
Okay, negative 1/2. I'm going to use the 1/2 because of the root. The negative because it's coming up from the bottom. Okay. So sin x plus 6, negative 1/2. So it started from the bottom, now it's here. Get it? Started from the bottom, now the whole team is here. Okay, take the derivative. You can't. Okay, what's negative 1/2 times 4 in the front? Negative 2. Then my sin x plus 6, don't say it out loud, but think about it. It's already minus 1/2, and now you're minusing another 2 halves, because that's the same as 1. So negative 1/2 minus 2 more halves, what's that? 3 halves. Very good. And then I have to multiply by the derivative of the middle. What's the derivative of sin x? What about the plus 6? That goes away, good. Okay, rewrite it. Negative 2 and cosine x get to stay on top, but my sin x plus 6 goes on bottom. It is to the 3 halves power. That means it's to the power of 3 and under a square root. So remember, the top is the power, the bottom is the root every time when you split those up. Okay? Alright, so we did some easy ones off the homework. Now we're going to do a couple of the harder ones. I'm going to write them up here. For those of you that don't have it, go back to your loose leaf paper, please. Okay, homework. Y equals negative 5t plus 3 squared. Number 10. What?
That's not number 80.
Yes, it is.
No. You just rewrote
Isn't that it?
Oh, you just rewrote it. Okay.
Yeah. Well, because some people don't have the homework because I got a bunch of new students and I didn't ask for enough copies. 9x squared plus 4. And then I'm going to have you do number 11. And then I'm going to bring you a Smartie. Because you're so smart. Okay. Yeah.
Number 8 is 5 over t.
Oh, I see why. Okay, you're right. It is 5 over. I didn't know what you were talking about, but now I do. It's 5, my bad. I did write it wrong. Over, and then t plus 3 squared. Thank you. Thank you for fixing that. Oops. Okay. All right. Do those 3. I'm going to also write number 9 up here. If you finish those easily, try number 9. 1 over t squared 3t minus 1. Okay, so you're rewriting first, taking the derivative. Some of them involve negatives, some of them involve fractions, but they all involve chain rule. You guys have a question? Yes. So if it's a t, the derivative is just 1. So think about like if it's the derivative of like 5x, you would have x to the 1. So 1 times 5 is 5, but then it's x to the y. 0. Well, then you don't have to write it. So if it's a 1t, it's like t to the 1. You do 1 times 1 is 1, but then it's t to the 0. Then okay. Oh, oops. It's too late. It's gone. We've already seen it. Yes? 1/2, because it's a square root. Oh, there's enough that you would Going after school today, so? Good. And y'all help each other if you have questions, okay? Okay, that is not helping. And say, oh, I already did this question. I'd like to know if we got the same answer. Want one? Ollie, you want one? Oh, you're welcome. Okay, let's check number 8. It's rewritten for you here. Negative 5, t plus 3 to the negative 2. What is negative 2 times negative 5? Okay, 10. What is the new power if I minus 1 from negative 2? Okay, but then what's the derivative of the middle? 1. Because think about it, that's a t, that's like an x. What's the derivative of 1x? 1. So the derivative of 1t is 1. Okay, how would I rewrite it?
10 over t plus 3.
T plus 3 cubed. Very good. Now, there should be something written on your paper from step 1, rewrite, to step 2. What is it? Okay, it needs to be labeled. These are not the same. The original you rewrote, but once you take the derivative, you need to label it either as dy dx is fine or y prime. Okay, let's look at number 10. Rewritten correctly, it should have been 9x squared plus 4 to the what power? 1/2. Y prime equals. Okay, put that on your paper if it's not there. My 1/2 comes down. What's the new power? Negative 1/2, right? Because I had a half, I take away 1. That's now a minus a half. And then what's the derivative of the middle? 18x. Now, if 1/2 and 18x are both on top, let's combine those. What is half of 18x? Okay, so or 9x on top, 9x squared plus 4 under a square root on bottom. And that would be like the perfect wrapped up pretty answer. Okay, but if you left it like this on multiple choice, or on free response, you would have been totally fine. Okay? Alright, number 11. Did y'all have time to get there?
Yeah.
Okay, some people didn't, so finish 9 and 11. If you didn't get to 9, it's over here. We did a rewrite like that in your notes. So if you don't remember how to do it, look back at your notes. So if I'm taking a derivative of, let's say, just 5x, would I need to on that? You just do 2 times 5 is what? The reason why is because 5 is considered as a coefficient. So that means that you don't have to use a special rule. It's just a number. Now, if it was this, 5x times x minus 4, that would need to be broken up into multiply that way. Versus if it's just a coefficient, you don't have to worry about that. Okay? Yes.
I like the days. Honestly, I think it's pretty cool. It's like,
Yep. And then
as long as it's
that's where we need to either group that for the squared or with the squared outside of it. Because it looks like it's only 9 times 3. There's so much crazy. Not minus 2. So 2 take away 3 on top.
St. Greek. Okay, at least they put a country and like a musical rule like this area.
And then don't forget the derivative of the middle. Huh? Yes, like this is like if f was sin x and g was that crap, that's f. Because g is plugged into that. Okay? Alright, let's do number 9. What should your rewrite have been? T squared plus 3t minus 1 to what power? Yes, good. Okay, then y prime, write the derivative, is negative 1 to the front. T squared plus 3t minus 1 is now to what power? Negative 2. And then the derivative of the middle? 2t plus 3. Okay, did I write it correctly?
You can do it again.
Okay, yes, but already I'm wrong. Parentheses. Okay, if that u prime has more than one term in it, you have to put parentheses. Okay, then on top, negative 2t plus 3. On bottom, t squared plus 3t minus 1 quantity squared. Question? Good? Or, oh, there was. Because I minus, so remember, I times it down and then I take away 1. So if it's negative 1 and then minus 1 more, that's where the negative 2 comes from. Okay? Alright, we don't really have time to do number 11 because we're like at yeah, the answer is here. There. Did you get it? So when you do 2/3 times negative 9, then you can reduce that. That was number 9 was right there. Do you see both? Okay, so 11's on the left, 9 is on the right. Okay? There's one on the front that's already showing that doesn't involve any chain rule. Number 13. What rule should that one be? Quotient rule. Okay? I will just print a new one during right now, 4th period. Huh? No, just staple. And then on your thing, just put like an X or something on the ones you did on your other sheet. Thank you. Actually, Jose, I'm going to just give these back to you. Thank you. Bye, y'all. Have a good day.
I've been trying to do it this whole week since I moved.